All right, next up is the associative property. I actually just did this lecture, but my phone wasn't recording it. Here we go again. All right, so associative is asking the question, does this operation, and the operation is the thing that you could see, the circle with the star, right? So the star with the circle around it, that denotes some ambiguous operation. A lot of times in math textbooks, you'll also see a plus with a circle around it. It means some not quite exactly stated operation. So that could be, addition, subtraction, multiplication, division. Just some sort of way of combining numbers into one combined thing, right? So what this associative property is saying is, can I do this thing, whether it be adding, subtracting, multiplying, or dividing, can I do it to A and B, and then figure out what that is, and then do it with C? Is that going to be the same as doing B and C together first, finding out what that combination makes, and then letting A come into the party later? So this is asking us, does it matter, who gets put together first? And I think of this, I think of it as associates in an office, like a group of lawyers or something. If I have two guys, A and B, sharing an office, and then person number C has their own office, hopefully that will equal the same amount of work done as if B and C are sharing the office and A has his own office. So it doesn't matter how you group them, the end result should be the same. That's the associative property. Remember that because that's what associates would do in an office. It doesn't matter how you group them and where they are, they should be getting the same amount of work done, hopefully. Okay, so let's check it out with different operations. So let's try it with addition. So addition is going to be the first one we check if it has the associative property. So is it true that if I do A plus B plus C, is that going to be the same as A plus B plus C, the only condition being that I do A plus B first and then add C? Or what if I do B plus C first and then add A on? Is that going to make a difference in the result of the answer? So we can try out a couple numbers, but I think 7 plus 1 plus 2, is that the same as 7 plus 1 plus 2? Okay, so this is 8 plus 2. I think that does turn out to be the same as 7 plus 3. And this is actually a really nice property that we can take advantage of. So when I'm adding numbers that are like a bunch of them, I had a long string of numbers, it doesn't matter how I group them. So maybe I think in my head, like, oh, it'd be nice to make 7 and 1 turn into 8, and then that does add nicely with 2. Versus someone else might think, I'd like to add the 1 and the 2 first. All right, now I still have to add the 7. So it doesn't matter the order in which you add them. You can look here first or you can look here first. Doesn't matter. Okay, cool. So addition, it does satisfy that property. And I know when we talked about logic, this isn't quite a proof, right? Finding one example, I'd have to show it's true for all the numbers. But this is something that's axiomatic. So let's change out the operation here. Let's see if this holds with subtraction, and I'm suspecting it's false. And luckily here with this logical reasoning, I can just find one example to show that it's not true, right? So if I find one example, I've proven it's not true. So my addition was a little bit more hand-wavy, right? Look, it worked. I think it keeps working. Here I'm going to show that it definitely doesn't work for subtraction. So let's try out a number. Let's just do the same one. 7, take away 2, take away 1. And now I'm asking the question of, so it's appropriate to put a question mark above the equal sign, is it truly equal to 7 take away the result of 2 minus 1? All right, 7 take away 2 is 5, take off 1. Does that turn out to be the same as 7 take off, what does this turn out to be? 1? I'm thinking no, right? So this is 4. 4 is definitely not the same as 6. And so I urge you to try out a couple examples on your own, maybe where this isn't a 1, because maybe the 1s at the end gets confusing to you, because the 2 minus 1 is the same as just minus 1. So try out a couple examples on your own and really be assured that the associative property does not hold over subtraction. So for subtraction, I'm going to say no. And now multiplication is A times B times C always going to be the same as A, but now we're going to let B and C come together first. And it is true. You can try out a couple examples on your own. And now in the assignment section, I'm going to make an open assignment for you to submit an example of division and explore whether or not division holds over associativity. So you need to answer this question. Does this always hold for numbers? Does A divided by B then divide by C, does that turn out to be the same as A divided by the result of B divided by C? So can I do this division first and then that? Would that be the same as doing the second division first and then dividing with the first one? So I'll let you try that out, and I'm going to open assignment in the assignment section on Lima, not in the discussion section. That's the section on Lima you need to be looking. This pen's kind of running out. So look in the assignment section, and there you'll have to submit you exploring whether or not division has the associative property.